Okay, this is Unit 4, Lesson 9. We're going to look at how to write an equation when we're given some information for an exponential function. So what you need to remember is our pattern. So there's our pattern, where A is your initial value, R is your rate of growth or decay, and N is your time frame, the number of times that it's increasing or decreasing. So the initial value is never too bad when you're given a set of data. You can usually look at your data and figure out, hey, there's where I'm starting, so there's my initial value. The tricky part is your growth rate or your decay rate. So I'm looking at this table and I notice that it goes up every number. The population is increasing every year. So I know that if it's exponential, it has to be multiplied by the same thing every year that it's increasing. So if I know that it multiplies by the same thing every year it's increasing, I should be able to find out what it's multiplying by taking 2 consecutive years and dividing them. And when I do that, I get about 1.0239, I believe, or 1.024. And you can try it. You can divide each pair, 9395 divided by 9175. You can do the next pair, you can do the next pair, and you're going to see they all work out to about 1.024. So my equation, the population, will be what I started with, 8,750 times 1 plus 0.024 to get our 1.024 to the n for the number of years. Remember to tell me what your letters stand for. So n equals the number of years after, what did we start at, 2005? And P of n is the, of course, population. So once you've got your equation, you're good to go to use it. Use your equation to determine the population in the year 2020. That means I would be finding my population, 1,750 times 1.024. Just be careful with your exponent. The year started in 2005, and we're treating our equation like this is 1, that was 0, this is 1, this is 2, this is 3, this is 4 years after 2005. So 2020 would be 15 years after 2005. So my exponent would be 15, not 2020. So watch that sometimes. And then all you need is your calculator. And what have we got? 8750 times 1.024 to the exponent 15, which gives us about 12,488. Because it's population, we're not going to have point or a decimal of a person, so we round it to the nearest whole. Therefore, in 2020, there will be about 12,488 people. Last one. Use your equation to determine when the population reaches 20,000. So we've done one like this before. This one's different than the last one because this time, instead of asking me what the population is, it's telling me the population. So I know when I take 8,750 times 1.024 to the exponent n, the answer I'm going to get is 20,000. So we want to solve it. That means we want to move the numbers away from the variable, which means I'll take my 20,000 and divide it by 8,750. Because it was multiplying on the other side, it'll become dividing on this side. And I'm going to end up with, my calculator turned off. There we go. 20,000 divided by 8,750. So we've got about 2.2857. This is the kind when I'm trying to figure out the exponent that I have to guess and check. So I have to make myself a little table, pick numbers for the exponent, keep typing that exponent in until I get as close as I can to about 2.28 or 29, somewhere in there. So we're going to pick somewhere to start. I'm not sure where we're going to need to start. Let's try, I don't know, 20. Pick a number. And I'll type it into my calculator, 1.024 to the exponent 20. And I see that I've got 1.607. So I'm a little bit off. So I'm going to increase that by quite a bit. Maybe try 50. 1.024 to the exponent 50. And now I'm too much. I've got 3.2733. So I'm going to look somewhere in between, maybe 35. So it's a little better. I'm at 2.293. I'd say that we are pretty darn close right there at 35. That means use your equation to determine when the population will reach 20,000. It doesn't mean that in the year 35 it'll reach 20,000. Remember, because we started with the year 2005, and that means that in 35 years there will be about 20,000. So I've got to add 35 years to 2005, which will put me at 2040. Therefore, in the year 2040, the population should be about 20,000. All right, there we go. So really the word problems of writing equations all come down to using that pattern of equation and understanding that when you're given a set of data, an exponential growth, and everything goes up by a constant amount, that you can figure out what your growth is by dividing and take your initial amount from your table. All right, let me know if you have any troubles.